Hello everyone. So today we will be discussing about SP3 hybridization by taking an example methane. So methane, if you see the formula, we have one carbon atom and four hydrogen atom which is in the terminals. So if you see the structure, the carbon will be in the center and we have four hydrogen in the corners. And what type of bonding is expected in methane is covalent bonding. So as we already know, a covalent bond A covalent bond is formed by sharing the electrons. So a bond has been formed by sharing the electrons between the carbon and hydrogen. So now here we will also be discussing about mainly about the hybridization. So now how is this sp3 hybridization is creating this particular structure, that is methane, and what is a bond angle and all that we'll be learning in detail. So now let's get into the topic. So let's take the carbon. So atomic number of carbon is what? 6. So we know the configuration. So if you don't know the configuration, kindly go back and read the configuration. It's 1s2, 2s2, 2p2. So this is the configuration where 1s is in the first shell, K shell, and 2s belongs to the second shell, so Kl shell. Next we have an element that is hydrogen, whose atomic number is 1, whose configuration is 1s1. So if you see, hydrogen is an element who wants to be stable like helium, whose atomic number is 2. But except hydrogen, all other elements wants to be stable having 8 electrons in the configuration, that we already know. So now let's see how this hybridization is taking place. So intermixing of atomic orbitals are called as hybridization. Okay, so now let's take carbon. As we already know the configuration, 1s2, 2s2, 2p2. So this in 2s and 2p, I'm just showing you the electrons distributed in this way. So we have p electrons, px, py, pz, px, py and pz, and here we have 2 electrons, and here also I have 2 electrons. Is that clear? But this is in the ground state. So ground state, so as we know, the electrons are never been stable. So if it's an atom, the electrons never be in the stable state. It will always go from a ground state to the excited state. Again, it will lose energy and come back to the initial state. So like that, the electrons keep jumping from one state to another state and it comes back to the ground state. So this is in the ground state. Initially, this is the configuration. So 2 electrons in 2s and 2 electrons in 2p. So in excited state, what happens? One of the electrons from 2s is going to jump into pz orbital, empty pz orbital. So let's see what happens to the configuration. So electrons are represented in this manner. So here 2 electrons, so I have shown half arrow on opposite side, opposite spin, and then I have the electrons jumping from the ground state to the excited into empty pz orbital. So 2s, I have 1 electron in 2p, px, py and pz each having 1 electron each. So now what happens? Hybridization is basically intermixing of atomic orbitals. So they are going to mix with each other, and how much of atomic orbitals are mixing, that many hybrid orbitals are also obtaining. So how many atomic orbitals I have? 1, 2, 3, 4. So how many hybrid orbitals I'll expect? 4 hybrid orbitals will be expected in this case. So now S, if you see S, what is the general shape? Spherical. What is the P general shape? Dumbbell. Okay, so now how many P orbitals are undergoing hybridization? Px, and we have py and pz. So py and also pz orbitals undergoing hybridization. So these are the 3 p orbitals along with 1 2s orbitals undergoing hybridization. So 2px, 2py and 2pz. Okay, this is this structure and all these three are destructured. When they combine together, they don't have a shape like this or this. They mix together to form an hybrid orbital, something like this. So like that, how many parental orbitals are involved in hybridization? 4. So like that, I'll get 4 hybrid orbitals. So 4 hybrid orbitals is obtained as a result. So this is an hybrid orbital. So these hybrid orbitals will join together and form a shape like this. Okay, so that small head can be just shown like this, no issues. Okay, and if you see, every hybrid orbitals having one electron each, 1 1 1 and 1. And as we know, carbon valence electron, it is having only 4 valence electron. But how many more electron it requires to complete its octet? It requires to complete its octet by receiving 4 more. And who's giving that 4 more? By 4 hydrogen. By the 4 hydrogen. And now the hydrogen will come into picture. Hydrogen configuration 1s, and S shape is spherical. So hydrogen with 1s, hydrogen with 1s will come into contact, and they are going to share its electron with the carbon. So carbon's electron, hydrogen's electron, when they combine, one s orbital and one p orbital joins together to form sigma bond. One s orbital and one p orbitals will always form a sigma bond. So as a result, one s and one sp hybrid orbitals will form sigma, sigma, sigma bond. Therefore, if you see the structure, let's come back to the structure. We have 4 sigma bonds, and what can be the shape of sp3? So you can see they are like a tetrahedral. What is the shape? So the shape is tetrahedral. Okay, and we have a bond angle which you just need to remember, 109.28 slash. Okay, so this is the bond angle. And now it is sp3. Sometimes in the exam they will ask you what is the composition of sp3. So it's always better to remember this is a composition we are taking for 100. So here we have s and 3p character. So it's just 25% of s plus 75% of p character. It's very important for remembering for one mark question. Okay, so this is all about your sp3 hybridization. So kindly go through it. Thank you so much.